Hello, Austin, and welcome to this session. Thank you for coming in good numbers for this after lunch session. So, my name is Nilesh Bhosale. I work at IBM's Storage and Software Defined Systems CTO office. And the topic I'm going to talk today is finding needles in the unified storage haystack. So let's go into that. So as we can see, so we all of us know this very well that we are experiencing a very huge data explosion, right? This is a chart from IDC that talks about the data that we are having today in the world is exponentially growing, right? So even individually we can see that the data on our phones, the tablets, it's growing so fast and so much. And at the enterprise level, it is going at petabyte scale every month or so, and it's reaching exabyte limits. And by 2020, it is going to be very huge data. So what's the problem of having so much of data? We have seen a lot of big data solutions out there, and what we can see today for a storage admin or a CIO or a person who looks at the data, the pain point today is like it has become a junkyard, data junkyard, right? So every customer, every enterprise has been generating hundreds of TB of data every day, and it's growing. It's growing at massive scale, and it is reaching petabytes and still growing. Data is split across multiple silos, right? So the world is not black and white, right? So there is, when we say huge amount of data, you can store it in cloud, it's very cheap, but you cannot store everything on cloud. You keep something on-prem. So on-prem, you can have object on-prem, you can have hybrid storage strategy, and some of the data, you want to keep it in files as well, because you have your legacy applications that are running on files. There are some high performance big data applications, Spark and Hadoop, etc. They require file access. So you need to have your data in files as well, and you want to keep it on cloud, and you want to leverage the cloud storage opportunities. So you want to put them in object storage as well. So data is split in different islands, file, object, and you can consider block as well. But in a sense, you have huge amount of data that is now split across multiple silos, and there is not a quick way to get insights into your data. It's kind of virtually lost. You have virtually lost the data, right? So you don't have an ability to quickly get grab the data that you want, you are interested in. So in a sense, as I said, it is becoming a data junkyard out there, as we can correlate it to the internet, junkyard of internet that we used to call in early 90s, right? When before the emergence of good search engines like Google and these things, which gave you access to the data you wanted to, providing a very good search engine capability. So what do we need today? So we need quick insights into our data, and not only the storage performance, capacity, these stats. There are some tools that provide you that run on top of your storage systems and provide you the insights into how much performance that your storage system is giving you, what is the capacity usage, etc. But what is there inside the data, that is not very visible, right? And that's what we want to extract, and that's where that we need we need an efficient search capability that can look into your data and understand your data, because your data is not structured data, right? It's an unstructured data that you put into object store or files. You need to have some structure around it to get insights, and that can help you to do analytics and do analysis around your data insights. And all of this we want without duplicating the data, right? We don't want to put all of our data into an index or into a database and then create a catalog and search it. We don't want to duplicate data. So we want a good enterprise class search engine solution for the storage and for data. So the solution would need a capability to search files and objects. Should support different storage systems, different platforms, should support custom tagging. So with data, you get some tagging or some metadata around that, but we want to put in some custom metadata or tags to your data, so that help you extract that when you need. So this system should provide that. It should provide some visual insights into your data and should help you to do intelligent data analytics, mining, data warehousing. There are a lot of such applications that you can run once you have good insights into your data, and that can lead to having a cognitive storage solution. So yeah, so how are we going to do this? What is the thing that can help us get insights into the data, right? So as I said, we are having all the unstructured data, files, objects, etc. We cannot really make sense of it. It's not database, the structured data, right? So what can help us is the metadata that is around this unstructured data. It can be system metadata, your file stats, etc. It can be user metadata that can be defined as tags to your data. In object world, it is quite obvious. You put associate metadata to your object, right? So it can be user metadata, or it can be application defined metadata, wherein you run some applications, you extract some insights into your data and put those as metadata or tags to your objects or files. This is applicable to both files and object, and there can be some metadata extraction tools that you can make use of. There are some open source tools also available there, like Apache Tika is one of the open source tools, which can help you extract metadata from certain type of data, and then you can tag that or put that into the searchable metadata index. As I said, metadata is you can think of as a fingerprint or a DNA of your whole data that can get you insights into your data, right? So there are some examples that I have mentioned over here, some from geospatial, music, media, entertainment, and images. There is a whole lot of metadata that is available that we need to make use of and leverage. So this is an overall architecture. I am not going to get into too much of design and implementation details, but this is an overall architecture that we can use to extract and get insights into our data. And there are a lot of open source tools available out there, so we can make use of that. And if we do our thing right, these tools can help us really get what we want. So here in this diagram, what I'm showing, you have file store, you have object store, but then you can have some service that is running regularly, like a nightly scan, doing a nightly scan of your data, extract some metadata out of it. It can be system metadata or custom metadata or application defined or extracted metadata that you can find out. And then you can feed that into some indexer application, which then puts it into some database. We are using here Elasticsearch as a NoSQL database, wherein you can feed in the metadata and as key value pairs, and then it indexes those. Elasticsearch is one of the topmost search engine NoSQL database. It's open source, and it provides a clustered database, right? So it can scale high. So you can put your metadata into that. Then from the Elasticsearch stack itself, there is a tool called Kibana, which plugs in very well with Elasticsearch and can give you very good graphical insights into whatever you have stored into your Elasticsearch index. So this is an overall architecture that we use. And then there are some examples that I'll go over, and this is a chart that I prepared from files that are stored in the file system. Looking at their extensions or file types, we can find you can get the extensions. From the extensions, you can understand what type of file it is. Is it a PPT or a PDF or JPEG or doc, etc. And then you can tag those things into your index searchable database, and then you can easily get the insights into your data. What type of files, how the distribution is there on my file system. You can easily get insights into that. You can do a lot of things. You can put ranges of sizes, and then you can see how my file system is distributed. How many are the files between less than 1 KB, less than 10 MB, or around 1 gig or more than that. You can do charts around that as well. Another example, this is a split bar chart. And here with the object storage data, I'm generating a split bar chart over here. When the object was inserted into your or created into your object store based on the timeline and based on how many counts each category of object that you have based on the country that is associated with the or tagged with your object. You can have photos that you upload into your object storage or photo sharing application. Now you can tag which country this photo was taken into, and then you can draw these insights into your data. Then this is a map. So this is also comes from Elasticsearch itself. You can plot a graph or a map. You can plot onto the map that using the geo points that you geotag your photos, right? Using the geo point, which are coordinates, latitude, longitude, you can plot this kind of a map, and you can see from where these photos are being generated. This is small sample set, but if you have very huge sample set, it can give you much better insights, definitely. So there is so from IBM we have published an beta for object storage metadata search, and it is out there, published last month and available for download and trial. So trials are for free, so you can try it out. So that gives you a capability to search your objects based on the metadata. Then yeah, thank you for coming. And for the thank you slide also, I have used this tag cloud or a word cloud, you can say, and this also can be generated with the help of Kibana from your Elasticsearch index. So you have various kinds of metadata that you have stored. You can generate tag cloud, you can generate maps, different types of charts, which can give you very good insights into your data. So thank you very much.